All right, let's do 8e. This time our function is y equals negative square root of negative x. Well, what does a normal square root look like? A normal square root graph starts at the origin and opens up and to the right. Well, this thing has a double flip in it. It's got the negative out front, which means it's going to be flipped down. And then it's got that negative on the inside as well, which means it's actually going to be flipped horizontally as well. So our final result should look like this black bit right here. Negative in front of a function flips it in the vertical direction. Negative in front of your x value flips it in the x direction because it is with x and x is horizontal. So this will be flipping it horizontally with that square root on the inside and vertically with the square root on the outside. So let's draw some axes right here. I guess if you think about it, knowing what we know about the domain and range of this function, axes like this would make more sense. I know I'll have my first point at 0, 0. I know I'll have my next point at negative 1, negative 1. And I know that because the original function has its point at 1, 1, and we've done a double flip, so it's going, instead of up and right, it's going down and left. And I want to find at least 3 key points. How do I find my next nice key point? Well, think about nice x values you could square root. You could square root 4, and you would get 2. What that tells me is if I go to negative 4, because of these flips, if I go to negative 4, I should be down at negative 2. So my next point I can show right there at negative 4, negative 2. And you don't need to really plug in points to get that. You just need to have an understanding of how the original untransformed function works. And it works just like a square function works, just backwards.